In this video, I'm going to introduce you to another formula for curvature. So curvature, we've seen this formula and we've seen this formula. Now, when you're working in 2D, so this is in 3D. If you're working in 2D, if you have a simple y equals whatever graph involving x, you can use this formula here. You can use this formula here. So let me give you an example. So let's say you've got a graph of y equals e to the power of x. So remember, if you have any graph, you can always turn it into its parametric form. So even if you have y equals e to the power of x, you can always turn it into its parametric form. So I can, looking at this, I can visualize it like this. I can discard this and just have the x-axis as t, and then the height would be given by f of t. So now I can, even though we started out with y equals e to the power of x, we can turn into f involving t. So looking at this, f of t would be, well, starting with this, you can always turn it into this. So this thing here, we can visualize it as this, t and then t. So now we can start to use the formula. Well, anyway, let's use the formula. Hang on. So the curvature is given by this. So looking at the formula, we need to work out f double prime. So differentiate it, f prime, differentiate again, f double prime. F double prime evaluated at time equals 3. So that this thing here would be 3. Remember, we are trying to find out the curvature of, let's say, y equals e to the power of x at x equals 3. At x equals 3. So that's the same as saying when t equals 3. So we are trying to find out the curvature somewhere around here. So f double prime evaluated at 3 will be e to the power of 3. So the magnitude of this would be e to the power of, it won't be a negative number. It won't be a negative number. Well, anyway, this thing here will be e to the power of 3, and then we need to evaluate f prime. So this block here will be e to the power of 3, but then we've got to square it. We've got to square this. So when you square this, it will become e to the power of 6. So you would put this into here. That will then give you e to the power of 6, and then add 1, and then to the power of 3 over 2. So we are blindly following this formula here. So the curvature is approximately this. Okay, so the curvature at let's say x equals 3, the curvature here will be given by this, approximately this.